As humans, we continue to impact the world around us. We grow infrastructure, we expand our reach, and we create connections with others miles away. But how does our growth impact the planet? We are going to investigate our impact through three lenses: the spreading of invasive species, habitat destruction, and pollution. We have spoken at length about invasive species in this course up to this point. You took a trip to the Hawaiian Islands where we saw a complete overhaul of an ecosystem through invasive species such as the feral pig. You saw the feral goats of the Galapagos and the invasion of the cane toad in Australia. We even looked at invasive species right here in Central Texas, the red imported fire ant. The introduction of the invasive species have rewoven the ecosystems of our world. They continue to increase the local biodiversity by increasing the presence of new species. However, this is leading to a decrease in the overall biodiversity of our planet. It leads to a homogenization of ecosystems, creating the same ecosystem around the globe, thus taking away the unique and rare environments we cherish. As we continue to grow, we not only introduce species, but break down existing habitats. Many of us think of city development when we picture human infrastructure. However, urbanized developments only cover about 3% of the Earth's surface, making it a minor contributor to habitat destruction. Another system accounts for 40% of the Earth's surface: cropland and pastures. The development of industrial agriculture has changed and continues to change the global environment. It leads to a fragmentation of habitat. Every time we build a new highway, we are fragmenting the environment. This leads to a decrease in continuous habitat. This even extends to the ocean floors due to bottom trawling. This is when fishing boats drag their nets along the sea floor. This creates the same fragmentation we see on the terrestrial surface. Data has shown that greater amounts of continuous habitat leads to greater biodiversity. Thus, as we continue to decrease the amount of continuous habitat, we see decreases in biodiversity. This is due to the edge effect, resulting in organism isolation. They can't hide deep in a forest from predators. It provides less protection from the elements for trees and plants. However, some species benefit from this, such as the brown-headed cowbird, who practices parasitic nesting. Overall, habitat destruction and fragmentation lead to a loss of native biodiversity and the expansion of invasive species. The most common impact we have on the environment is pollution. Instead of discussing this in terms of items, we are going to investigate pollution on the atomic level, first starting with nitrogen. Nitrogen is one of the most abundant elements, making up 78% of the Earth's atmosphere. This atmospheric nitrogen is converted into usable nitrogen through the process of nitrogen fixation. This is when living organisms in the soil convert nitrogen gas to ammonia. However, when we look at the global nitrogen fixation, we see about 50% is created through this process, with a small fraction broken apart from the energy released from lightning. The other 50% comes from anthropogenic impacts: fertilizers, fossil fuel combustion, agriculture. This means that anthropogenic effects have doubled the overall supply of global nitrogen. Thus, it is estimated that 80% of the nitrogen in your body is from anthropogenic impacts and not natural fixation. Our next element of interest is phosphorus. Phosphorus is added naturally to the global cycle through rock weathering. However, it has been estimated that mining phosphate-bearing rock has doubled the global availability. We also see high concentrations being introduced into rivers and streams through runoff waste from livestock and poultry farming. Our next element of interest is sulfur, a bright yellow crystalline solid at room temperature. Just like phosphorus, it is naturally introduced through chemical weathering, which releases sulfate ions into local streams. It can also be expelled through volcanic activity in the form of sulfur dioxide. However, this is not a common event in today's day and age. However, it can be released as sulfur dioxide through another process: industrial waste. This results in a doubling of the dissolved sulfate in rivers and streams. We have seen the doubling of sulfur, phosphorus, and nitrogen due to anthropogenic effects. But we have one more element of interest: carbon, the building block of life as we know it. There are several methods in which carbon is introduced into the global cycle through anthropogenic impacts. The first being the burning of carbon-based things, such as burning wood, trash, or fossil fuels, or even through the combustion occurring within your own automobile. It is also introduced in the form of methane through decomposition, primarily from the industrialization of agriculture, such as the poultry and livestock waste, or even the breakdown of trash at your local landfill. This increase in global carbon has sparked a political battle. However, the data does not lie. If we look at the global carbon dioxide concentration, we can see that within a short amount of time, the global carbon dioxide level has increased dramatically, currently reading 413.76 parts per million. According to geochemical evidence, the last time the atmospheric carbon dioxide was well above 300 was 34 million years ago. What does this mean though? The overabundance of nutrients in lakes and streams is called eutrophication. This might seem great. We have plenty of nutrients, but it actually leads to major changes. For instance, it allows plant life to grow in dense packs. As the plants die and are metabolized by aerobic microbes using oxygen, the oxygen levels in water drop dramatically, resulting in the death of animal life and even O2 dead zones. This alters the structure of the ecosystem. With high concentrations of carbon dioxide in the atmosphere, more is dissolved into our ocean. This leads to the creation of carbonic acid and the acidification of our waters. This acid dissolves limestone, i.e. calcium carbonate, which is the main component of many marine life skeletons. Our world is changing right before our eyes. Many argue that it is nothing to worry about. It has happened before. Just like I said, we have seen these levels before, roughly 34 million years ago. The crucial part they leave out is the rate at which it is occurring. This is not something that is happening over eons or even thousands of years, like we saw 34 million years ago when volcanic activity was resulting in a gradual increase in carbon dioxide. This is happening in a blip of time, a short segment in the history of our Earth. We see species disappearing at alarming rates. Corals and amphibians are at an extreme risk. Will these species be around for the next generation? Think about Hawaii. Why were the invasive species so damaging to that ecosystem? They didn't co-evolve with the native organisms. The change was quick, and native species did not have the time to adapt. Think about what biodiversity is. It allows survival. It helps an ecosystem become competitive and resistant to change. What happens when that system becomes homogenized? Will we have time to adapt? Will other species have time to adapt? Now is the time to take action and apply your knowledge. Don't sit idly back as our planet is pushed to the brink. Do your part and conserve the beauty that is all around us. Save the planet that is filled with diversity, connection, and wonder.